Alright, in this section here we're going to be talking about rational expressions with integer exponents, and we're just going to be simplifying. So let's remember here what a rational number is first off. So a half is a rational number, 3/4 is a rational number, 2 is not a rational number, that is an integer. This is with integer exponents. So if I were to say x squared over y to the third, okay, this is a rational expression. We have a rational number here. And so x might be equal to 5 and y might be equal to 2, and we would plug that in and we'd have a rational number. Alright, we're going to actually start off with some stuff that's not rational numbers first off, so we can kind of do a little refresher here on adding exponents, subtracting exponents. Let's say, for example, I had 2 squared times 2 to the third power. So if we want to simplify this, we would say this is 2 because we have the same base, and you would add your exponents, and of course this becomes 2 to the fifth, which I believe is 32. But anyway, so we add exponents, okay, as long as our bases are the same. So if I were to have 2 to the fifth times 2 to the negative 2, right, the bases are the same, you add exponents. This is 2, 5 minus 2 is equal to 2 to the third, which ends up being 2 times 2 is 4 times 2 is 8. Right? 8. Okay, now for an actual, maybe a rational expression here. 5 raised to the fourth power over 5 raised to the second power. Now I can take this and move this denominator up to the numerator. And when we do that, we change the sign of this integer here. It's a positive 2. When we take it into the numerator, it becomes a negative 2. And of course now, because our bases are the same, this is 4 minus 2, which can reduce down to 4 minus 2 is squared, and of course that's 25. So we have 5 4's in the top. We have 5 4's. We have 4 5's in the numerator and 2 5's in the denominator, and we just canceled 2 of them out of the denominator and 2 out of the numerator, and you were just left with 2. Alright, that makes sense, hopefully. Okay, something a little bit more complicated. What about negative? Well, I don't know if this is more complicated, but we're going to throw a negative in. Over negative 7 fifths. Now you notice we have 4 in the top, 5 in the bottom, so we can cancel 4 of those out in the top and 4 out in the bottom, and we would just be left with one of them in the denominator. Of course, you can always take this negative and bring it out front. Now remember, we can do this the old-fashioned way, taking this up into the numerator, but that becomes a negative, adding exponents, and so you have 4 minus 5, which ends up with negative 7 to the negative 1, but now we want to take this back down into the denominator, right, because it's a negative, bring it down, but we don't write a 1 here, right? But then we always want to bring this negative out front, okay? Alright, another way of looking at that. Okay, let's see. Let's do one more of those. Negative 2 squared over negative 2 to the sixth. Now there's 2 in the top, 6 in the bottom, so we're going to knock this out, or you know what, I'll just write it like this. And so we're going to take the denominator and bring it up. Because it's a positive 6, we take it into the numerator. And this becomes negative 2 to the negative 6. And then of course we can say negative 2, we can add our exponents. And this becomes negative 2 to the negative 4. Of course, then again, we don't want to write this with negative exponents. We want to write everything with positive exponents. So we're going to take that down into the denominator. And of course, this is negative 2 raised to the 4th power. And that's going to be, let's see, 2 times 2 is 4. So that should give us 16. Right. So 1/16, that's what our original is equal to. Okay, if I have 4 to the negative 1, and it's all raised to the negative 2, what we do here is we're going to multiply our exponents. So this becomes 4 to the negative 1 times negative 2, and of course this can be rewritten. Negative 1 times negative 2 is just 2, and this becomes 16. So this 4 to the negative 1, remember, is 1 to the 4th as a rational number, and it's all raised to the negative 2. So this is just another way of seeing this. What you can do here is you can flip this 4 over 1, and now instead of writing negative 2, we write a positive 2 here. Okay, another way of looking at this. This is, you can distribute this 2. This is 4 squared, and of course 1 squared. And of course this becomes 16. Now I could have wrote this 4 over 1 as just 4, right? 4 squared, which is 16. Alright. Alright, what happens if I had 5 to the 0, and that was all raised to the negative 4? Well, 5 to the 0 is 1, but let's just try it this way. 5 raised to the 0, right, you multiply exponents, but of course 0 times a number is just 0, and a number raised to the 0 is just going to always be 1. All right. If I had 2 to the negative 3 plus 4 to the negative 1, and we want to get this into a single fraction, right, which is going to end up being a proper fraction, you would write this as 1 over 2 to the 3rd plus 1 over 4. And this becomes, let's see, 2 times 2 is 4 times 2 is 8, so this becomes 1/8 plus 1/4. Now we got to get a common denominator. I'm going to multiply 2 over 2 here, and this becomes 1/8 plus 2 over 8. Now we have a common denominator, so we end up with 3/8 is our answer after simplifying all of this. Alright, let's see if you can get this one here. This is 3 to going to be to the negative 2 minus 3 to the negative 1, and it's all raised to the negative 2. So I can rewrite this as 1 over 3 squared minus 1 over 3. Now we're just going to focus on what's in parentheses here. I need to get a common denominator. This is 1/9 minus 1/3. So we're going to multiply a 3 over 3 here so we get a common denominator. So we end up with 1/9 now minus 3/9, which becomes 1 minus 3 over 9, which is negative 2/9. Okay, so now that we have negative 2/9, what we're going to do is go back up. Remember, everything is raised to the negative 2 power. So we would say negative 2/9 raised to the negative 2. Well, we can take this negative 2 here now and bring it up to each one of these. That's a 9 right there. Or the shortcut way of doing this is just to flip this thing. And so you could say negative 9 over 2. Okay, that's just a whole lot faster. Raised to the 2 power. And of course now we have negative 9 to the second power and 2 to the second power. Now you notice I took the negative and just brought it into the numerator up here, okay, and put parentheses around it because of the negative. Notice I didn't put parentheses around the 2 in the bottom. That's fine. But negative 2 squared is going to be 9 times 9, or negative 9 squared is 81, and 2 squared is 4. What happens if we had 9 over 8 and it was all raised to the 0 power? Well, remember, everything raised to the 0 power is going to be 1. So there you go. That was a little review there, a little refresher. How about if I had 5 over 8 and it's raised to the negative 1? Well, remember that you can flip this fraction, so you have 8 over 5. And we flip the fraction because we have a negative here, so we can write a positive now. But this is just 8 over 5 raised to the first power, which is just 8 over 5. Alright, let's look at, I don't know, I think let's start working some stuff with some variables in it. How about I had 7x to the 8th times y squared, so we're going to jump right on into the water here, and it's not too deep, I promise. X to the 6th and y. Okay, well, we have an x to the 8th and an x to the 6th. Now I'm going to rewrite this as 7. I'll just rewrite this 7 over 2 here and get it out of the way. We have x to the 8th times x to the negative 6. Now bringing this up into the numerator, change the sign, times y squared times y to the negative 1. I'm bringing this up into the numerator also. Now what do we do here? We add our exponents. We look at our like terms here. We got two bases that are the same, so this becomes x 8 to the minus 6 times y 2 to the minus 1. And of course we have this 7/2 out front. So 7 over 2 times x. So this becomes 2, and y 2 minus 1 is just 1. So there you go. It's been simplified all the way down. 7/2 x squared times y. Alright, let's look at another one here. So let's say we had 15 x to the 11th and y to the 7th, and that's all over 3 x squared y squared. So I'm going to rewrite this. First off, 3 goes into 15 5 times, so let's just get that out of the way. Bring this x squared to the top, so that becomes x to the negative 2. Y to the 7th times, bring this y squared to the top, so it becomes y to the negative 2. Now we add our exponents. And so we have y to the 7th, then minus 2. So this becomes 5x to the 11 minus 2 is 9, and y to the 5th. So that is now be simplified completely down. All right. Let's say we had, not that, 3y to the 9th over 2x to the 10th, and all of this is going to be raised to the second power. So what we're going to do here is I'm going to take this 2 up here and do just like this. This is 3 squared times y. Now you multiply exponents, so this would be 9 times 2, which is 18, over, now we have to also do it to the denominator, 2 squared times x, and 2 times 10 is 20. And so this just becomes 3 times 3 is 9, y to the 18th over 4x to the 20th, and there's not any more than we can do there. So that's it, completely simplified down. Three x to the 4th over y, and it's all raised to the 3rd. So try pausing the video and seeing what you get as the final answer while I work this out. 3 to the 3rd times x 12th, that'd be 4 times 3 is 12, over y to the 3rd, and so this time we get 27 x to the 12th over y to the 3rd. So that will be your final answer. Let's see here. Oh, man. Two x to the 4th over 5 y to the negative 2, and this is all raised to the 3rd. So this becomes 2 to the 3rd times x, 3 times 4 is 12, over 5 to the 3rd, and negative 2 times 3 is negative 6. Right. And of course we can rewrite this. This is 2 to the 3rd, so that's going to be 2 times 2 is 4 times 2 is 8, x to the 12th. This is 5 to the 3rd, which is 125. Now I'm going to take this y and bring it into the numerator because we want to write our answer with positive exponents. That looks kind of sloppy. Let's rewrite this. 8 over 125 times x to the 12th times y to the 6th. How's that? Alright, so let's get a little bit more complicated here. Oh man, I always forget something. I'm not going to go into what it is I forget, but there's something I got to clear out before I do something on some software I'm using here. I always forget it. 2x to the third, and it's all raised to the negative third. Okay, so we're going to take this negative 3. Actually, okay, there was a shortcut. If you've been following my work on some previous problems, you know that if we have a negative up here, we can flip whatever's inside, and we're going to do that. Right, instead of going through all the algebra to get there, let's just take the shortcut. Now I can write this with a positive exponent. Okay, now what we're going to do is take 2 raised to the third. It's x, you multiply exponents, so this becomes x to the ninth over 3 raised to the third. And this is 2 times 3, which is 6. And of course, the only thing we can do here now is just go ahead and take 2 raised to the third, which is going to end up being 8 x to the ninth over 3 to the third is 27, and y to the sixth. Okay? Right. Okay, this will be a fun one here. We have negative 3 x to the fourth, y to the seventh, and that's going to all be raised to the third power, and then over 2 times x to the negative 4 times y to the third, and it's all raised to the negative 4. So this is raised to the negative 4, so that means we can take this up into the numerator. But I'm going to go ahead and start simplifying some of this stuff. We have negative 3 raised to the third. So we multiply exponents. 4 times 3 is 12. Y to the 21st, right? 7 times 3 is 21. And bringing this stuff up into the numerator, this is going to be 2x to the negative 4 times y to the third, and it's all raised to the positive 4 because we brought this whole thing up here. Okay, negative 3 to the third is going to be negative 27, x to the 12th, y to the 21st times, and 2 raised to the fourth times x. Negative 4 times 4 is negative 16, and y to the 12th. 3 times 4 is 12. What a mess. Negative 27, x to the 12th. Let's look for some like terms. We have an x to the negative 17th, so let's pair them up. Now, I should have brought this 2 to the 4th out here, but I don't know. Let me just write it like this for right now. Times, we have a y to the 21st times y to the 12th. I can bring this over, so this becomes negative 27 times 2 to the 4th is 2 times 2 is 4, so that'd be 16 times x. So we have 12 minus 16, and that's going to give us negative 4. So my brain shut down. We have a 21 and a 12. Let's see. So this is y. So we add our exponents. That's 2, 3, 33. So we're almost done here finally. Should have put a parentheses around that. This is going to end up being, so this becomes negative 432. Now this is x to the negative 4, so I'm going to take that back down to the denominator. We want to write our answer with positive exponents. And so we do. X over 4. There we go. Alright, this is probably going to be our last one. That probably won't be the last time I do that. Let's see, 5x to the third over 2y to the fourth. So what you need to do is, once I write this, pause this video and try to figure this out yourself. We'll compare answers. Alright, so pause, pause, and pause. Okay, so this is, we can multiply exponents here. 5x to the third over 2y to the fourth. And that's exactly what we're going to do. Multiply exponents. Negative 2 times negative 1 is just 2. So now I can go ahead and write this as 5 squared times x. This is 3 times 2 is going to be 6 over 2 squared and y. And so 4 times 2 is 8. And so we end up with 25 over 4 and x to the 6th over y to the 8th. So that's what you should come up with. Okay, last one. X to the 8m over x to the 2m, and we want to simplify this down. So this is x to the 8m. Right, taking this into the numerator, this becomes x, making this a negative. So whatever this sign is out front, when you take it up to the, when you switch it, either numerator, denominator, the sign always changes. 2m, x 8m, and we add our exponents, negative 2m. And of course, these are the same, these are like terms, so this becomes x to the 6th m. So this all reduces down to x to the 6th m, and I think I'm going to be finished on rational expressions, just simplifying these. I'm sure I'll have more in the next section that are similar. Alright.